Okay, glad you guys are back, and we're going to do the second part of this lesson that I did yesterday. So yesterday I focused on this first formula to find the arc length, but today we're going to go over converting degree to radian and radian to degree. So I'm going to take these two formulas, I'll put them on the other side so you guys can see them as we're working the problems out. Okay, so I'm going to flip. So this first section, we're going from degree to radian. So that's going to be the x degrees, I'll just put the formula right here, times pi over 180. Okay, that's the same formula that was on the other side. So you're just going to take your degree measure. So I'm going to do 30 degrees times pi over 180. I'm going to reduce the 30 over 180. Now you guys can do this a couple different ways. I'll show you on this first one. You can probably reduce that one in your head, but I'll just go ahead and show it on the calculator. So you can use your fraction template. So you can go alpha y equals, and choose the first one. So 30 over 180 gives you 1/6. Or you can just do 30 divided by 180 equals, and then you have to hit math 1, and that'll convert it back to a fraction. So you get 1/6, or you get pi over 6. Notice I did not multiply the pi into it. I kind of held that out because your radian always has to contain the pi. So 30 degrees is equivalent to pi over 6 in radians. Remember, a radian is like the arc length measurement when you're thinking about a circle. Okay, so let's keep going. So this one will be 45 degrees times pi over 180. Then if you reduce the 45 over 180, and then you attach that to the pi, you get pi over 4. So you would get 1/4, and then you just have to attach your pi back onto it. So that's the equivalent radian measure to 45 degrees. 360, so 360 times pi over 180. So that reduces to 2, right? 360 divided by 180 is 2, and then attach your pi. So that's an important one. A full circle, one full rotation is equal to 2 pi in radians. So this one, 550 times pi over 180. This one I'm just going to dump the zeros, and I get 55 pi over 18. That one's easy to reduce. And then the 900 times pi over 180. And I believe that goes in there 5 times. So that's just going to be 5 pi. All right. Okay, so this last section now is going the opposite way. So we're going to start with the radian and convert that into a degree. So this one, the formula is radian times 180, all divided by pi. So if you notice on the degree to radian formula, it's pi over 180, but when I have to do the opposite way, the radian to degree, I take the reciprocal and that flips. So it's 180 over pi. So I'm going to take the radian, pi fifths times 180, all over pi. Now the pi's will automatically cancel. Now you got to remember, if there's nothing else up there with the pi, you got to put a 1. So then you have to do 1/5 times 180, which equals 36 degrees. So 36 degrees and pi fifths, are the same measurement. It's just this one's in degrees and this one's in radians. And that's your arc length, and this is your angle. Okay, let's do it again. So 7 pi thirds times 180 all over pi. So the pi's cancel. And you guys just have to do 7/3 multiplied by 180. So if you type that in your calculator, you will get 420 degrees. Okay, so 3 pi over 4 times 180 all over pi. Cancel your pi's and do 3/4 times 180, which equals 135. So I'm going to take 3 pi. Now this one doesn't have a fraction, but that's okay. Just do 3 pi times 180 all over pi. So pi's cancel. And you just do 3 times 180, which is 540. So this is just, a lot of repetition. You guys are getting some practice with these. So 15 pi over 4 times 180. Some kids take shortcuts on these. They know the pi's are going to cancel, so all they do is just 15/4 and multiply it by 180. So you guys can, take the shortcut. I'm just showing all my work in the lesson. Okay, now that closes out Act 31. So let me grab a unit circle, because I started building the unit circle today with the kids. Okay, now, let's see how much I can show on here. Okay, well, one thing you guys can add, up here at the top, just put the radius equals 1. Okay, radius is 1 on this circle. And then I also mentioned, and I'll use some highlighters for this, that you can't really see it on this one. You pretty much just see the circle. But this is your x-axis. Okay. And this is your y-axis. So what's happened is they put the circle on a coordinate plane. So the circle is like laying on a coordinate plane. And then you have all these points, you can kind of see them right here. These are ordered pairs that are created by plotting the points. Then they end up intersecting the circle. Okay, so now I'm going to go through this kind of quickly. You guys can slow it down if you need to. So my radius is 1, so I know this ordered pair is 1, 0. Okay, and this is at 0 degrees. So this is like the beginning right here, starting point. Now I'm going to go this way. So I'm going to go counterclockwise, 90 degrees. So this is 90. And this would be the ordered pair 0, 1. I'm going to go another 90. So this is going to give me 180. And this will be the ordered pair -1, 0. Then I'm going to go another 90. This takes me to 270. And this will be 0, -1. I don't know if you guys can see this. Hopefully you can. And then back around 360. And then that's back to 1, 0. Now, since I have a coordinate plane, I know that this is quadrant 1. So in quadrant 1, it's always positive, positive. And over here in quadrant 2, it's always negative, positive. And then down here, quadrant 3 is negative, negative. And quadrant 4 is positive, negative. All right, so that's, you guys know that. You should know that. That's just your old quadrant work from when you first learned the coordinate plane. Okay, now we're going to start building this circle by filling in the first 3 coordinates here in quadrant 1. So the first 3 ordered pairs. And to do that, I'm going to start going by 60 degrees. So I'm going to start with this one. So this is 60. So I'm going to go every 60. So over here, this will be 120. This will be 180. Go another 60. And where does that put me? 240 right here. Another 60 puts me at 300. And then another 60 puts me at 360. So I'm going to figure out the ordered pairs at the ends of each of those 60-degree marks. We already know that one. So it's really the ones that are out in the quadrant. It's not on the X or Y axis. Now to do that, I'm going to show a little triangle. Let's see how I want to do this. So I'm going to use this as my one side. I'm going to drop a perpendicular and I'm going to form a triangle. This is a 60-degree angle right here. Okay, so now I have to think of my special right triangles. So that would be my arrangement, and I know the hypotenuse, I know this side right here, that's my radius, is going to be 1. All right, so the distance from the center of the circle to a point on the circle is your radius. So I know this is 1. So for this triangle, that's my hypotenuse. Okay, so to go backwards, I have to divide this by 2, and that'll give me my x. And then I have to multiply by radical 3, so that gives me radical 3 over 2. So that means this distance, this is my short leg, this would be 1/2, and the long leg would be radical 3 over 2. So this ordered pair up here would be 1/2 radical 3 over 2. So this is my X maneuver, this is my Y maneuver. Okay, now I'm going to erase this triangle. I don't want to clutter up my circle too much. So what's going to happen is now I'm going to kind of go into each of the other quadrants, and the same arrangement of points, the same ordered pair is going to be at the other 60-degree marks, except your signs are going to change. So if it's in the second quadrant, it has to be negative 1/2, positive radical 3 over 2. If it's in the third quadrant, they both have to be negative. Oops. Need my 1/2 right there. And then over here has to be 1 positive and 1 negative. So let me double check those. So those should all be the same arrangement. Just the signs change. All right, let me check my time. Okay. All right, now I'm going to do the 45. So it's going to come here. I'm going to drop that. Okay, now I've got to think of this differently. This is going to be the other tic-tac-toe. X radical 2. My hypotenuse is 1. And then I divide by radical 2. Now when you divide by radical 2, you have to rationalize. And just for the sake of time, you get radical 2 over 2 for both of your legs. So this distance would be radical 2 over 2, and this distance is radical 2 over 2. So I'm going to get both positive here, 1 negative, positive here, both negative here. That's a little sloppy. And positive negative here. All right, so let's put those angles in there. So I know this is a 45er, and that's why I use the 45, 45, 90. So every 45 degrees, so this will be 135. This will be 225, and then 315. Okay. So the last one, what happens is it ends up being the 30, 60, 90, and this is a 30-degree angle. So I'm going to go every 30 degrees. Now most of these are filled in, so that's going to be 30. 120 to, so this will be 150. 210 here, and this will be 330. And what happens on this one is it's the same chart we used for the first one, for the 1/2 radical 3/2. The only difference is your long leg is now the radical 3/2, and your short leg is the 1/2. So it looks like this. So they just trade places. So then over here, it'll be a negative radical 3/2. Down here, both negative. And then in the fourth quadrant, positive, and then negative. So let me double check if this is what I went over today. I know I went pretty quick with you guys, but I've got a class coming in here in a minute. I think we're good. I did not fill in these other little lines or the radians, but we're going to do the radians in class on Thursday next week for you Cohort B kids, okay? So I think that's it, but just email me if you guys have any questions or concerns. All right, see you later.